Good morning, everyone. My name is Rina Tanaka. I'm a third-year student in Kyoto University and Faculty of Agriculture. Today, I'm going to talk about automated hay harvester. First, I'll introduce what is an automated harvester like. This is a picture of automated harvester. It is an experimental model based on the New Holland speed rower, and it moves like this. It tracks the crop boundary between cut and uncut crops, and when it arrives at the end of the crop row, it turns automatically and keeps harvesting. So, to perceive crop lines accurately is necessary for automated harvesters. So, our objective is to find a method which takes the boundary line between cut and uncut crops accurately, and so that we can make hay harvesting more accurate and efficient. Devices are RGB cameras which are mounted on the harvester, and a processor named SunSpark 20. Images from RGB cameras are processed by SunSpark 20, and according to the processed data, the harvester will move automatically. This is a method of crop line tracking system. This is a model of the field. This side is cut crops, and this side is uncut crops. First, the RGB cameras scan the color data in the unit of each line, and then the processor processes the data by using the Fisher's linear discriminant. This is a diagram of the result. Each point is indicates the relation between the position and color function. As you can see, these points are divided into two groups. Then, by the Fisher's linear discriminant, we can decide what point is boundary between two groups. Then we can decide a likely boundary point. In this diagram, a likely boundary point is this. And continuing this algorithm in each lines, we can decide the boundary line between cut and uncut crops. And field tests were taken in alfalfa fields of 4 different conditions in Pennsylvania, Kansas, and California. This is part of result. Boundary line by processor marked by white points, and it's mostly corresponds to the real boundary. This is area of cut crops and uncut crops. And the maximum cutting speed was 7.24 kilometers per hour, while the typical cutting speed was 4.02 kilometers per hour. So, visual processing system was succeeded in outside. Conclusion. By using RGB cameras and proper processing systems, automated harvester can detect the boundary line between cut and uncut crops accurately, and the cutting speed is higher than manual cutting. But it's only experimental stage. So for practical use, adapting a GPS system to confirm the result of visual perception system is necessary. This is the end of my presentation. Thanks for listening. If you have any questions, please ask.
Okay, okay, so across whose color is very similar to run this system, how distinct my condition is
How to
find the boundary.
detect the boundary between the similar color crops.
Yeah.
Sorry, I'm not sure, but in this case, in the alfalfa fields, its alfalfa crops are green, and cut crops are brown. So I think there is no problem in hay harvesting.
Cut crop left or mobile harvesters remove down way? If remove down way, round color.
Oh, brown color.
No?
Yes, I think it's a brown color.
Oh, so that's easy.
Yes.
Maybe. Yes.
Is there another way to harvest the field without looking at the edge and making sure you get everything?
Looking at the edge.
You're guiding the machine by looking at the edge. Is there another way to achieve the same perfect cut of the field without looking at the edge?
You mean, is there any ways to operate the harvester automatically? The paper I referred said that it's possible with GPS positioning system, but it's better to combine GPS systems and vision perception systems together. Okay.
Can I follow up? So if you have a patch in the field that's bare because the crop failed or whatever, then you're going to follow the edge that is not very accurate. True? Maybe she doesn't understand my English, but that's what you
You mean moving along the edge is not enough?
The edge goes away because the crop failed. So you're driving along and edge disappears.
Once the harvester moves along the edge. The line, new edge appears after cutting.
That's okay.
Okay, new edge appears, so the harvester turns and it moves along the new edge. Okay.
If you couldn't find the edge,
The edge is gone
It is gone.
because of a flood, for example. Field
Oh.
floods, edge is gone.
I see.
Now what?
Then I think it can't find the boundary. But if there is still a color difference between crop area and not crop area, I think it can find the edge again.
okay, no crop.
Yeah.
After all harvest,
Ah.
what happened?
Sorry, I have no idea. I don't know.
That's a good answer.
Any other comments or suggestions?
The presentation, can I forgot what slide, you have a slide on the ground with white dot on the edge. Can you explain that a little bit to us? Slide number 2, yeah, that's the one, 7. Yeah.
This right.
What do you mean by boundary line marked by white points?
After processing, as shown in this slide, 1 point per one line is marked as a likely boundary point, and after processing all lines in this area, each boundary point forms into one line. So the harvester will move along this line.
Okay. Any other comment? Maybe Shao-Chen, you have your own project on image processing. You have any comments too? That's a very technical, very high level of technical stuff. Maybe she doesn't know that. Okay. Any other suggestions? Okay. Yeah, you practice well, and yeah, you can improve more some English communication. His English is just very native compared with the other. They already got used to their English here in Japan, so maybe Japanese like. But his English is, he just came from US, yesterday, the day before yesterday, 2 days ago. So,
My Japanese is no.
I'm sorry. I'm sorry.
so the very native speakers speak like that.
Okay.
Of course, they also are native. Anyway, okay, thank you very much. Yeah.